Saxon Advanced Mathematics, Lesson 24. This is a two-parter, you guys. It's a little bit longer. Lesson 23 was 17 minutes, I think. That was really exciting. This one is a little longer. I'm sorry. Let's just go for it. Okay, subs of trig functions is our first topic. This is, I think, semi-fun. We're going to use those two special triangles, the 45, 45, 90, and the 30, 60, 90. And the problems look something like this. Example 24.1, it says evaluate cosine of 60 degrees plus the sine of 45 degrees. Okay, so what we're being asked to do is figure out the cosine of 60 degrees using the triangles, figure out the sine of 45 degrees using the triangles, and then add those two values together. So what I like to do is something like this. I'm going to figure out the cosine of 60 here, the sine of 45 here. I'm going to write my answers at the bottom, and then I'm going to add them and put my final answer there. Again, it's just a way to organize the page. I wish I would have written this more in the middle so I had the whole page, but I write big, so it's fine. All right, so cosine of 60 degrees. First thing we need to do is draw our triangle. And I imagine that I've drawn the whole equilateral triangle, but then chopped off the bottom half. So I remember this is the full length, this is the side that gets chopped in half, and then the third one, I remember is that. This is the angle that didn't get chopped. This is the one that did get chopped. And there's the corner. Okay? Now, for cosine, that means we're standing up here. Here I am. Yay, I'm floating in the air up here. Cosine is, Oscar had a hold, right? Cosine is a hold. So it's adjacent over hypotenuse. From the 60-degree angle, the adjacent is 1, and the hypotenuse is 2. So that means that I am going to be adding one half for the cosine of 60 degrees. Isn't it fun that something that looks so hard can turn out to be something so simple? And here's the plus sign. Goes in the middle. Now we do the same thing to find out what the sine of 45 degree is. I draw my triangle. Here we go. It's chopped this way. Each of these sides are 1. This is square root of 2. And then these are both 45. So that's the nice thing with this triangle. We never have to do this float up in the air thing because we can always stand down here because these are the same. Okay, sine is Oscar had. So that is, the opposite is 1, and the hypotenuse is square root of 2. And then I see that there's a problem down there. I don't want a radical in my denominator. So I'm going to fix that right away by mentally multiplying top and bottom by square root of 2. And so this will become square root of 2 over 2. Make sense? So now I can copy that down here. And my final answer can be written as 1 plus the square root of 2 over 2. And that is the value of that plus that. Oh, it's kind of fun, isn't it? You just play with these little triangles and these cute little baby numbers. I love that they're all just 1s and 2s and 3s. I think that's so fun. Okay, let's do another one. And this format helps keep us on track and not going crazy. Next one. Are you having fun? I am. Remember to write everything down, you guys. I'm sorry if I'm going too fast. I'll try to go slower. Example 24.2. Evaluate tangent of 30 degrees plus cosine of 45 degrees. Okay, so this is what I like to do. That, and then this, you know, you're just kind of guessing how much room you're gonna need. All right, so, and then we draw the appropriate triangle here, and this gives you a million opportunities to practice your triangles. And, you know, if you feel like you've really got these triangles down and you're drawing them over and over and over, you can simplify this. Like if you want to draw them once up at the top of each page in your homework, or if you want to draw them once in one problem and then refer to it, I'm okay with that. Just make sure you're really rock solid on these before you start cutting any corners. I'm going to keep writing them out because I want you to see every single time how I'm thinking about it. All right, this is my 30. This is my 60. This is the full one. This is the chopped one. This is the weird one. I'm at 30 degrees. I need the tangent, which is equal to over Arthur, which is, oh, I forgot my arms. Opposite is 1. Arthur is adjacent, which is square root of 3. I multiply that mentally by square root of 3 over square root of 3 to rationalize that, and I get this. That should be enough room for the other problem. So this is going to be square root of 3 over 3, and then the plus sign I'm going to bring down. I leave myself a little room here so that I can write the answer this way. I don't know why. Why don't I write it that way? I don't know. The rings maybe, but I just leave myself some room to actually add them. All right, cosine of 45. Here are my 45s. I could put that in there and that in there. That helps. And it reminds me that for now, we only use trig functions with right triangles. This is 1 square root of 2. I'm standing here as always. Cosine is, Oscar had a hold. The adjacent is 1. The hypotenuse, square root of 2. I rationalize it, square root of 2 over 2. Make sense? It is worth mentioning, if you didn't notice it before, that on the 45 degree triangle, the cosine, the adjacent, is the cosine is adjacent over hypotenuse, but it's exactly equal to the sine, right? Because these sides are the same length. We'll talk more about that later, but that's an interesting thing about these triangles, is that for a 45 degree angle, sine equals cosine. Interesting, right? Okay, so now we're ready to go. Square root of 2 over 2. Okay, so that's our answer, but wait a minute. Before we can add them, we have to have matching denominators, right? So we don't have an equal sign here, so what we need to do is we need to do top and bottom adjustments. Our least common multiple is 6, so this one will multiply by 2 over 2, and this one will multiply by 3 over 3. That will give us 6 in both denominators, so then we'll have 2 times the square root of 3 plus 3 times the square root of 2 over 6, and that's our final answer. So there at the end, we just have a little, you know, fun with denominators. Yay! Happiness. I didn't put smiley faces on my exponential graphs. I honestly believe they need them. And I didn't put one on there either. Ah! You guys, I'm falling down on the job. Come on. All right. That was the other lesson. This one and this one. This one takes a rough bend there, doesn't it? But this is okay, right? The main thing I would be looking for, going back to exponential functions, I'd be looking for this point, and a nice little tail. Okay. But we're not talking about that anymore. We're talking about trig functions. So I just can't get enough of those exponentials. Exponentials I love because it seems like they should be really hard, but they're not. Same for these. I think these are fun because they look so scary. But then when you realize what they want, it's like, oh, I can do that. Tangent of 45 degrees plus 2 times the tangent of 30 degrees. Now, what the heck is that? That's not what we've seen before. All right, well, let's just keep calm and see what happens. This is exactly the same. We draw this triangle. Again, I'm okay if you take a few shortcuts on this. One. I mean, to write it every single time might make you nutty. Okay, tangent is over Arthur. It's 1 over 1, which equals 1. Huh, okay. Now, for this, first we're just going to focus on this, the tangent of 30 degrees. All right, we can do that. This is our 30, this is our 60, 2, 1, square root of 3. Tangent is over Arthur, and we're 30 degrees, so that means we're here. Okay, I didn't put my degrees in. Can't have that. Okay, so over Arthur, opposite is 1. Adjacent is square root of 3. We can rationalize it right away. We multiply it by square root of 3 over square root of 3, so we get this. That's all beautiful. That's the tangent of 30. Now, all we have to do to get this full value is multiply that by 2. So we have 1, that's this, plus this times 2. So it's 2 square root of 3 over 3, right? All you have to do is multiply it by 2. There's nothing tricky about that. So there's the tangent of 30 degrees, and then I multiplied it by 2. And now our last step is just to combine them by creating matching denominators. 1 I'm going to rewrite as 3 over 3. And our final answer equals 3 plus 2 times the square root of 3 over 3. The angels are singing in heaven because they love our trig problems. Aren't those fun? And as much as it's nice to push buttons on the calculator, I really enjoy the kind of self-sufficiency that comes from drawing our own triangles and knowing these values and being able to combine them, calculate them and combine them as we are. Now, you would be very wise to ask, but why? Why on earth would you want to find these different relationships and combine them like this? And the answer I have for you is that we're not going to find out in this level of mathematics why you would want to do that. Well, maybe a little toward the end. We'll use it for greater purposes. But for the most part, we're just learning how to manipulate the numbers. So don't worry too much about where this is going or what it means. Just understand that we can do it. And we can do it using our trig, our special triangles, and it's all glorious and easy and kind of fun. Okay, that's all we get to do for our trig, kids. Now we're going to do part B, which is called combining functions. And I believe we covered this in the red book last year, but we're going to go through it again. The idea, I'm going to save the harder one for last. Sometimes I question the order John puts the problems in. I would like to do, let's see, we're up through 24.4. Oh, no, we're not. We have one more of these problems to do. So I got excited. Let's do example 24.4. Ready? All right, so what we see is that John's doing this whole thing of putting a coefficient on these values. Again, we'll find this and then we'll multiply by that. we'll find this, we'll multiply by that, we'll add them, we'll simplify. So it's not getting really all that much harder, it's just getting a little bit longer and a little more kooky. All right, 30 degrees. Now the good news here is that these use the same triangle, so I'm not gonna draw it twice, but I am gonna go ahead and draw it again. I can't get enough of these guys. This is our 30, it's the one that got cut. This is our 60. This is the long side, this is the short side. And that's that one. Okay, sine is Oscar had. 30 degrees, we're standing here. And so the sine of 30 degrees is the opposite over the hypotenuse. Beautiful. So that's the sine of 30 degrees. Now what we need to do is multiply that by square root of 6. Yeah, I'm just checking to make sure that I didn't copy the problem wrong or any crazy thing like that. So I'm going to multiply square root of 6 times 1/2. That's square root of 6 over 2. That's in good shape. I don't know what I'm going to have to do to add it to this one, but it's fine the way it is. I've got my denominator rationalized. I feel good about that. All right, now let's turn our attention to this side. Tangent of 60. So I'm just going to borrow this picture. I'm going to draw myself in up here. Tangent is over Arthur. Oscar had a hold over Arthur. Tangent of 60 degrees means I'm standing here. The opposite is square root of 3, right? Because from here, this is the opposite. The adjacent is 1. Okay, so that's square root of 3 over 1. Now, because it's a little bit messier, I'm going to multiply 1 times the square root of 2 times the square root of 3 over 1. I'm going to do this multiplication in the box. The other time I did it in my head and just wrote the answer down here. This one's a little more complicated though, because square root of 3 over square root of 2. Now I have to rationalize this, and my final answer is going to be square root of 6 over 2. Oh, well, isn't that interesting, right? It's the same thing. And now, when we add these together, it's 2 square root of 6's over 2, or just square root of 6, because those cancel. Okay? So, this has gotten a little more complicated because we're putting these wacky coefficients in front, but that's just a little multiplication at the end. The process of finding the trig values is still the same. Draw the pictures, orient yourself, find the right values, and then multiply by whatever extra stuff. Again, we're practicing calculations that we will use at some time in the future, and right now, if it all seems arbitrary and random, then we're fine. Then you're right in place, because that is arbitrary and random. But we'll just have fun doing it. Okay, now we can talk about combining functions, and there are 2 problems. I'm not going to rewrite the title. We'll just fake it. I'm going to do example 24-6 first because I think it's easier, and then we'll go back and do 24-5. Here's the problem. If the f of x equals x plus 2 and the g of x equals x squared plus 3, find, and then it tells us 4 different things to find. So first we're going to find the f plus g of 6. Now, this is what we mean by combining functions. John's telling us to add these 2 functions together. That's what this means. He's saying find out what happens if you combine those functions and solve them for 6. Now, there's 2 ways we can do this. The first way is to solve for f of 6 and g of 6, and then add, add the answers. Let's try that, okay? The f of 6 equals 6 plus 2, which equals 8. The g of 6 would equal 6 squared plus 3. Notice what I'm doing. I'm just copying these functions down and plugging 6 in wherever I see an x. Okay, 6 squared plus 3. This is 36 plus 3 more equals 39. So if I do it this way, I get that the f plus g of 6 would equal 8 plus 39, which equals 47. So that's my answer. Okay, that's one way to solve this problem. And honestly, most students find that the easier way. The second way is to add the two functions together first. Oops, that shouldn't be there. Okay, so this time what we're going to do instead is we're going to actually combine the functions first and then run the value through. So the f plus g of x is going to be equals x plus 2 plus x squared plus 3. See, I'm combining the functions first. I'm building a new machine rather than just cranking through the separate answers in the individual machines. I hope that made sense. It made sense to me, but that's not saying that it makes sense to you. All right, so now I'm going to clean this up. I'm going to say that the f plus g of x equals, let's put them in order, x squared plus x plus 5. Now we can calculate the f plus g of 6, which is what John cares about. That would equal, and now we just do the same thing. We just fill in the buckets. 6 squared plus 6 plus 5. Okay, so this is 36 plus 6 more is 42 plus 5 equals 47. Yay, we got the same answer. Okay? In all the problems we're going to do in this example, we have our choice of either combining the functions like this and then running the numbers through, or running the numbers through independently and then just combining them at the end. Either way always works. We'll mix it up in our examples and do a little of both. So that was A. That was when we were adding. For B, John wants us to subtract f minus g of 6. Okay, so we'll do number 1 for that way. And we've already figured this out because we know that the f of 6 equals 8, and we know that the g of 6 equals 39. So if we're subtracting them, then the f minus g of 6 would equal what? Negative 31, right? Okay. This illustrates a really nice point. If we're working in functions and we're naming things and playing around with different combinations, it becomes really easy because we can carry our answers forward very easily because everything's named. So we have no problem in knowing exactly which values are the same. It keeps everything neat and super cool. All right, so we've added functions, we've subtracted functions. Let's now multiply. I'm going to copy these over to the next page. F of x equals x plus 2, and g of x equals x squared plus 3. Okay, so now for this third one, C, John wants us to multiply, which he designates like so. Okay, We could do it the other way where we find this answer, find that answer, multiply them together. And because we've already worked on these and we know that this is 8 and this is what, 42? No, that's not right. It's 39. But we already know these values. It would make way more sense to do it the easy way. But let's do it the hard way. So what we're going to do is we're going to take the f value, x plus 2, and we're going to multiply it by this one, x cubed. So now we're doing the multiplication dance, plus 2x squared plus 3x plus 6. This is what we call the f times g of x. We literally multiplied together the two functions and got this new boy. Now we're ready to plug in our 6. And again, for every place where there's an x, we put in a 6. 6 cubed, well, that's going to take a little scratching. That's 36 times 6, right? 216 plus, that's 36. We double it, it's 72. I miss you guys. I wish you were here helping me with all these numbers. Right? And then our last step is to add them all together. And we have to write them in a column so that we can. I'll do it here. 216, 72, 18, 6. So there's 10, 22, 10, 11. Yay, that's right. So we can say that the f times g of 6 equals 312. Final answer. Yay. So that's doing it the long way. That's actually multiplying the functions first and then plugging in the 6. The other way is easier, guys. This way, we're making the numbers bigger than they need to be, and the other way we keep them small. So let D, we'll do it the easy way again. And this time it is f divided by g of 6. Okay, well, we already know that the f of 6 equals 8, and the g of 6 equals 39. We figured that out a long time ago. And so to make them into a fraction, we would just write the f over g. You could write it this way as well. You can write it in either format. Equals 8 over 39. And that's the right answer. And since we already knew these two values, back here, instead of going through all this work, we could have just said 8 times 39, right? 39 is the g of 6. 8 is the f of 6. 72. 24 plus 7 is 312. Look, we could have had it done that fast. Ay, we did it the long way, but it's okay. It all worked out. Okay, so that is adding, subtracting, multiplying, and dividing to combine functions. Pretty sure we did that last year. This example is slightly different. It's our last example. We're almost done. It's 24.5. And don't let this scare you. But here are our two functions. I'm throwing in a log. Don't worry, we don't have to simplify it, but John wants to use it just to freak us out, I guess. I don't know. Equals x squared plus 6. So here are our two functions, and he wants us to find something that looks like this. Oh, yeah, he doesn't want us to solve it. He just wants us to combine the function. Here's how I read this. And I wonder if it tells us how we're supposed to say it. I don't know. I say G eats F, okay? What that means is is that the F function is going inside of the G function. The G function is eating the F, so it's like in its belly, all right? So what we do is we're putting F inside of G. G is eating F. So we start with G eats F, and then we write this one into this one. So whatever we have for the F function, we put into the X place. See, I'm setting this up as the G function, and then where the X is, I'm gonna pour F into that spot. Okay, so this whole thing is the G, and then right here where the X is, that's where I'm putting the F of X in. And that is log X. So our final answer is, and I need to find out how to say that. I say G eats F, but I'm pretty sure that's not mathematically appropriate. Log X squared plus 6. That's the final answer. What's confusing, what everybody gets confused about these is when they see this notation, and that's a little circle. It's not an O or a 0. It's like a little bitty circle. You can see it in the book. Which one goes inside of the other one? And that's why I always tell myself it eats it. Because you know, okay, well, what you eat, that's on the inside. So the F is on the inside, the G is on the outside. That's the way it looks. That's lesson 24. I hope I spent less than 50 some odd minutes because it would be really nice to be done before you're exhausted. Okay, congratulations. I will talk to you on video chat this week. I'm looking forward to it. Great job, you guys. You're rock stars. I'll see you soon.